So these are the first questions that we're gonna do. There are still two more. So what you can do is that you can pause and you try it out, and then you can watch the solutions. Now they say a laptop depreciates on a reducing balance. So we know that this is a reducing balance. So we know that the formula for that would be A would be equals to P1 minus I for N, right? And they say of course, a laptop depreciates on a reducing balance method from 18,000 to 9,500 over 4 years. So we know that initially this laptop was worth 18,000. So initially we know that that would be P, right? So P would be 1.18,000, and at the end we know that it was worth 9,500. And then they said of course they didn't say anything about the interest rate or the annual, of course, annual rate of depreciation. Or of course they say determine the annual rate of depreciation. So we're looking for I. That's what we are looking for. And they said that this happened over 4 years, so we know that N would be 4. Now, one thing that the lovely part about the depreciation is that it only happens once a year. So we know that, of course, A, of course, that's the first. So A, in this case, we know that's 9,500. We know that P would be 18,000, and 1 minus. Now we're looking for I, that's what we're looking for, right? And then that would be for 4 years. Now, of course, to solve that, you would need to divide by 18,000 on both sides. And if you do that, you would get 995 over 180. That equals to 1 minus I to the power of 4. And now to get rid of that fourth root, what you would do, you would just take the fourth root on both sides. So that's what you would do, take the fourth root, and you would also do the same for that one. Of course, if you do that, what you would get for that side would be 0.8523 and some other decimal. So that would be equals to 1 minus I. Now remember that bracket that was around there would disappear since we took the fourth root. Now, of course, what you would do here would be to transpose this I on both sides. Of course, this I to this side, and you would take 0.8523 to that side. So this would be I would be 1 minus 0.8523 and some other decimal. But remember, I is interest. We know that interest is in percentage. So we would multiply that to whatever value that we're gonna get there. We would multiply it by 100, and what you would get I, of course, to be 14.77%. So in order for that laptop to depreciate from 18,000 to 9.5 over 4 years, so it would need to depreciate by the annual annual rate of 14.77%. Now, question 2, they say convert 10.5 percent per annum compounded annually to a nominal interest rate compounded quarterly. Now let's just go back a little bit. Now in grade 11, you learned that we have two types of interest rate. We have something that's called the nominal interest rate, and also what's called the effective interest rate. Now, an effective interest rate, this is when your interest rate, which is generally quoted per annum, which means per year, if it matches when it compounds, then that's called the effective interest rate. So the names have to match. What do I mean? So it could be per annum, per year. You remember annum means per year, so it could be per year, compounded annually. So the names match when it compounds, right? Per annum, per year, compounded yearly. Or it could be per month, compounded monthly. Or it could be per quarter, compounded quarterly, and so on and so forth. And with the nominal interest rate, in this case, the names do not match, so it's per annum, per year, compounded monthly, or it could be per annum, compounded quarterly. So the names do not match for the nominal interest rate. So that's what we learned in grade 11. Now, of course, if you read that, they say convert 10.5% per annum, which means per year, compounded annually. So the names match. So this is in fact an effective interest rate. Now, in grade 11, you learned that, of course, we have a formula that we use in grade 11 to convert, which says 1 plus I effective. That is equals to 1 plus I norm, or divided by M for M. Now, M, of course, does not stand for the number of months, but rather it still remains for the number of times interest is added. Now, of course, they gave us the effective interest rate. Of course, if you were to to make that a decimal, you would need to divide by 100, right? So you'd get a 0.105. So this would be 1 plus 0.105. That would be equals to 1 plus, they said, of course, per annum compounded. So we are converting it to a compounded quarterly, so which means that I norm would be divided by 4, because we have 4 quarters in a year, and that would be for 1 year. Now, of course, we are looking for I norm, so what you would do in this case is to get rid of that 4th root. Now, if you do that, what you would get, if you take the 4th root on both sides, you would get 1.0252 and some other decimal. So that would be equals to a 1 plus I norm divided by 4. Now remember that bracket would disappear, right, since we don't have that to the power of 4. Of course, in this case, what you would do next is to subtract the 1 on both sides. So this would be 0.0252 and some other decimal. So this would be equals to 1 I norm divided by 4. And in this case, to get rid of that 4, remember we are looking for I norm. So to get rid of that 4 would be we would multiply by 4 on both sides. So in actual fact, this would be 0.0252 and some other decimal. Of course, you need to write all of that, all of those decimal, because if you don't, if you round off early, of course your answer will change at the end. But remember, we're multiplying this by a 4, and this would be equals to I norm. Now remember, we're looking for I, and I would be of course it would be in percentage. Now remember, what you need to do would be to take whatever expression that you're going to get here, and you multiply it by 100. So it would be, of course, I'm just going to leave it as that. So it would 4 multiplied by 0.0252 and some other decimal. Of course, we would need to multiply whatever that we're going to get here by 100. By 100 right there. So of course, if you put that in your calculator, you would get 10.11. Of course, what you need to note is that the interest, of course, I norm is always less than the effective interest rate, because effective interest rate, it only happens once a year. So in this case, this I nominal would happen maybe 12 times a year, of course, if it's monthly. So they would take that percentage, so we would divide it into 12 equal parts if it was monthly. Of course, if it was quarterly, so it would mean that we would take that percentage, we would divide it by 4. So it would be divided by 4 times, because you can separate that into 4 installments. So we know that I norm would be equals to 10.11%. So that's what you would get. Now there's another way though that you could have chose to do this, and of course just doing that so that we have space right there. Now the second way that you would do this is to say, right, what if I were to invest 100 rand once per year of course once per year. If I get interest only once for 1 year, so that would be 0.105 for 1 year. And if you do that, you would get 110.5, so 110 and 50 cents. And then the second step would be to say, right, how do I get 110 and 5 cents from 100 rand if I don't use the 10.5, but rather I use some other interest compounded quarterly 4 times a year. So that would be 1 plus I to the power, of course, over 4 to the power of 4 there. Now, of course, the first step that you need to do here is to divide by 100 both sides. So you would get 1.105. That would be equals to a 1 plus I to the power of 4 or over 4 to the power of 4. So in this case, you can see that you're actually back at that which step? At that step right there. And again, you would do the same calculation, and you would still get the same answer. So that would be the of course the second way that you can choose to do this. Now this, okay, so this is the second question. We have of course one more that's left, and that will consolidate the lesson of today. Now they say convert 10.5 per annum compounded monthly. Now you see, let's see, they said per annum, per year, compounded monthly. So the names do not match. So if the names do not match, this means that this is in fact a nominal interest rate. And they said that we must convert that to an effective interest rate. So again, we can use the same formula, which says 1 plus I effective. Of course, in this case, we are looking for I effective, right? So that, no, let me just write it there. So of course, that will be 1 plus I effective. That will be equals to of course 1 plus I norm, of course, to the m or to the power m. Now remember, they gave us the nominal interest rate, right? And they said that we must calculate the effective interest rate. So 1 plus I effective would be equals to 1 plus, remember, if we convert that to a decimal, it would give us 0.125, and that was monthly. So that would be divided by 12 all over to the all over, of course, to the power of 12. Now remember, we are looking for I effective. Of course, I would subtract 1 on both sides. So in this case, on my left hand side, I will be left with I effective. So that would be 1 plus 0.125 all divided by 12. All of that will be to the power of 12. Now remember, I subtracted 1, right? So I would subtract 1 on that. And of course, we know that I, of course, is that's interest, and it is in percentage. So whatever value that I'm going to get here, I would need to multiply that by 100. And you would get that to be 13.24%. So that would be the I effective. Now again, you can see that I effective, as I've already said, that I effective is always greater than that of I nominal, because it only happens once a year. So that would be for that question. And the last one, of course, this is a timeline question. Of course, again, you can pause it and try it, and you can watch the solutions. Now they said that you deposit 5,000 into a savings account. So at T0, what we did was that we deposited how much? That was 5,000. And then they say 4 years later, you add another 2.5, of course. So at T4 would add another 2.5, right? And they say 3 years after that. So 3 years after T4, of course, 3 years after we have added 2.5, what did they say? They say you withdraw 2,000. So at T, so of course, 3 years after T4, it would be T7. So it would be at T7. So at T7, what did we do? We withdraw 2,000. So we will subtract that. And then they say, of course, they say, what was the interest is 9% per annum compounded quarterly for the first 5 years. So for the first 5 years, of course, the interest in this case was 9% compounded quarterly for the first 5 years, and then 7.5 per annum compounded monthly thereafter. So from T5 up to T10, of course, up to whatever the time they would ask us to calculate that. They would say that would be 7.5 per annum compounded monthly thereafter, and they say how much do you have, how much money do you have after 10 years. Now what we are really interested in would be T10 right there. Now one thing that you can't do, that you cannot do, is to take a 5,000 and add it with that, and subtract that, and then you invest it. You cannot do that. Why? Because you cannot, of course, you can only add money or subtract it if you know how much it is worth at the same time. So what do I mean by this? So 5,000 in 5 years, it cannot be a 5,000. Why? Because we know that if you invest money, it would grow, right? So in this case, what I'm gonna do is that I'm gonna try to find out how much will this 5,000 be worth after, of course, 10 years. And then I would ask myself, okay, after, of course, I would still take this 2.5 and ask myself, how much would that 2.5 be worth after, of course, a T10? And then I would do the same with that 2,000. And then I would add what I need to add and subtract what I need to subtract there. Why am I dragging all of them there? It's now, remember, I'm dragging them at the same time, right? Now remember what I said, you can only add or subtract money if you know how much it is worth at the same time. So I'm going to show you the other way that you could do this. But the first way would to take that 2,000 and find out how much will it be worth after a T10. And then you do the same. How much would that 2.5 be worth at a T10? And then you do the same with that 5,000. And then, of course, I would take these two, I would add them together and subtract that 2,000 at T10. So the first thing that you're gonna do now, remember, so we know that A would be equals to P1 plus I for N. So the first thing that I'm gonna do would be to find out how much would that 10,000 be worth after 10 years. But what you need to note is that something happened on our way, of course, to T10. Now, what is that? They changed the interest rate. So it was 9% per annum compounded quarterly for the first 5 years. So in this case, what I'm going to do, I'm going to find out how much, of course, would this 5,000 be worth after 5 years. And then I take that same 5,000, how much it would be worth at that time, and I would invest it, of course, for further 5 years there. So this is what you would do. I'm going to take that 5,000. I'm going to find out how much will it be worth at what? At T5. So that would be 1 plus, now remember, for the first 5 years, it was compounded quarterly. So at 9%. So this would be 0.09. All of that divided by 4. But of course, we know that we have 4 quarters, right, in a year. But for how many years? For 5 years. So that would be multiplied by what? By 5. And then whatever value that I'm going to get there, I'm going to take that same value, I'm going to put it back into the account, but now using 7.5% per annum compounded monthly. So I'll take whatever value I'm going to get here, and then I'm going to put it back into that account with the new interest, which is 7.5%. So that would be 1 plus 0.075 compounded monthly, but for further 5 years. So that would be 12 multiplied by how many years? So that would be multiplied by 5. So that would be the amount that we'll get, I would get for what? For that 5,000 at T10. And then I'm going to do the same thing with that 2.5. So I'm going to invest at that 2.5, of course. So I'm going to do that. So I'm going to take 2.5, and then I'm going to find out how much will it be worth at T5. Now remember, of course, that 2.5 would only be of course in the bank, of course in the account for 1 year, right before the interest changes. So that amount there would earn an interest for 1 year. Of course, that would be 1 plus of course 0.09 for a quarter. Of course, in this year we have 4 quarters in a year, and whatever amount that I'm going to get there, I'm going to of course put it back into the account. But for how many years in this? So for further 5 years, so that would be 1 plus 0.075, of course divided by 12. So that would be to the power 12 multiplied by the further 5 years. And then I'm going to find out how much will it be worth at T10. And then I'm going to do the same thing with the 2000. So I'm going to take, so that I added that into my account, right? So they said you add 2.5, but for that 2000 I subtracted it, right? So that would be minus. Now I'm going to invest it, so I'm going to put 2000. Now remember that 2000 of course I withdraw it after the interest is already changed. So in this case it wouldn't gain any of the 9%, of course compounded quarterly. So it will only earn an interest of course 7.5%. So this would be 1 plus 0.075 or divided by 12. But we know that the difference between T10 and of course the difference between T10 and T7 would be 3 years. So that would be 12 multiplied by 3. And then I can subtract them or add or whatever I need to add. So in this case, if of course you add this value, whatever value that you're gonna get here, with whatever value that you got here, and of course that you would get there's of course what I would advise is that you put your values more than once. Why? Because there's this strange value that I got for the first time, and I doubted myself. I said no, ikoni ngxaki, because the value that I got 500,083 rand and 65 cents, and I said no, it can't be. There's a problem here, there's something fishy. And then I did it for the second time, and I got the value of 12,000, of course 807 and 7.93 cents. So that's what I got when I pressed that for the third time. So for the second time I got of course for the second time I got that, and then I did that again to find if it was gonna match, and of course it gave me that same value. So what I would advise is that please to do that more than once, and you see if it gives you the same value, because this value that I got it wasn't right. So yeah, these are the mistakes that we make sometimes. So I would advise that you check that. So this is of course the end of today's session. Of course if you liked the video, you can always like the video, or share with your friends, or anyone who needs help in maths. And also if you've got a question here, you can always throw it in the comment section, or if you have any topic that you would love me to cover next. But yeah, this is of course the end of today's lesson. So I would say keep learning. Until next time, this is Sir Mike signing out.